Good morning, everybody. Good morning, YouTube. Good morning, Instagram. Again, we are continuing solving Khan Academy practice problems for the SAT right down the line. And if you haven't checked out Khan Academy yet, it's amazing what they've built. I no longer even use the College Board SAT study guides anymore because the two are the same. They've partnered up and now they've provided this free resource on Khan Academy with a dynamic set of practice problems that's constantly changing and growing, and the explanations are great. Everything is really, really awesome. So that's what I've been using to prep all of my students, and hopefully this resource will be something that you can come back and refer to at any time if you want an explanation. I remember one time a famous entrepreneur, Seth Godin, he once said, sometimes people might come to you and say, well, why should I start a restaurant? There's already restaurants that exist. But some people might like a certain type of food, might like Indian food. Some people might like steaks, etc. So the reason why I'm doing this, this is my long explanation for saying, hey, and you have the Khan Academy video explanations. I'm providing something else in a different style. Some people might like mine better. Most people might like Khan Academy's better, but it's there for you to check out and see if it vibes with your personality and what you like. So without further ado, let's get into the practice problems. Today, we are working on solving manipulating quadratic and exponential equations and expressions. So let's get right down to it. Again, if you're on Instagram, you won't be able to see me solve the problems. You'll just be able to see me talk about the problems. So if you want to check out me actually solving the problems on the whiteboard, go to YouTube, search for Scalar Learning, and you can jump on the live stream and see the shared screen. So I'm going to switch to shared screen right now. And there we go. Let us begin. Question 1. As always, we're doing these problems for the first time. It's more fun that way. But you never know. Pretty good. Could make a mistake here and there. Has happened before. It's always interesting, kind of fun. Okay, let's check this out. Again, this is something that you can use a calculator for if you need to. May have to. We'll see what happens. The following function gives the amount of money owed on a short-term loan after T weeks. Right there is our T variable. T probably stand right, time. Which numerical expression best approximates the annual interest rate, including any late fees? Annual interest rate meaning in a year. And they give you this nice conversion. Probably most of you guys know 52 weeks are in a year. All they're doing now is they're plugging 52 into this equation. So if we do that, it'd be 100 times 1.25 times 52 over 2. That's it. 52 divided by 2 is just 26. So then we can rewrite this as 1.25 times 100. And, I mean, this is basically it. We have, let's see, following function gives the amount of money owed on a short term. Wait, let me make sure I read this right. Which numerical expression best approximates the annual interest rate? Oh, I'm sorry. So we have the annual interest rate. So it would be 52, 26, and 100. I think, see, what's happening here is this is basically our initial amount of money, the 100. So sorry, this actually gives you the total amount owed, where they just want to know what is the annual interest rate. So it should be 0.25 to the 26th power. 0.25. Let's see, because it's growing that way. So let's see, well, any of these would be, this is almost it, but it's -1. This wouldn't work. Oh, wait, I'm kind of not sure exactly because, so let's see. We've got our interest rate here. So let me just step away for a second and try and make sense of this. This would be our interest rate, 52, and numerical, okay, annual interest rate. So if we do 1.25, let me actually use my calculator here. Let's go back, 1.25 to the 26th. So it's 1.25 to the 26th power equals 330. Wait, that seems huge too. So maybe I'm misunderstanding something. Let me make sure what's going on here. Amount of money owed, and so we got 52, so the 26th, 330. And see, this is what's throwing me off. Why do we have this -1, right? Because otherwise I would choose this guy. I would say 1.25 to the 26th. But why are they subtracting 1? And this is 1.25. But see, then again, they've got the 1 on here, and that's also off. The annual interest rate. I'm a little confused. 125. So it'd be 25%. And they want it as a rate. I'm pretty sure these are definitely wrong. I'm going to kind of go with A, but you know what? I'm not totally sure, so we're going to have to read the explanation. Hey, what's up, Jonathan? No, I'm not from Brazil. He's asking if I'm from Brazil. I'm actually I'm American, but I'm from India. That's where my family's from. So let's see what they say in the explanations, because I'm not sure. Oh, what was that second one? So let's see. Interest goes exponentially, right? So the -1 was confusing me. Let's see why they subtracted 1. After 1 year, the amount owed will equal 1.25 times the original amount. To find the interest, we need to subtract the original 100%, which as a decimal is, and then they take away the 1. Now I get it. All right. So what they were doing is, right, so remember I said I thought it should be just like 25% going up and up and up. And what they do is they have to take, it's like, usually in these interest equations, you have to write 125%. You put that in there, but that's just to say that it's growing. Okay, so the 100 is sort of to keep the original value, and then the 25% is how much it's growing every year. So if you want to know the interest rate, you have to subtract. You have to take out that 100%. So you'd say even though it's 1.25, the interest rate is 0.25 or 25%. So anyways, man, I got messed up there. That has happened before. It's not my first time. I do make mistakes here and there, but that one was. Sometimes I get thrown a little bit for a loop. All right, let's try this next one here. Now we've got. Let's see here. This guy. All right. The rabbit population in an isolated forest rises and falls depending on the population of predators. Within the year 2014, the population in thousands of, so here's population, in thousands of rabbits, M months after January 1st, 2014, so here's months, this is a quadratic equation. The population reached 10,000 sometime in February of the same year, I guess. At what other time, given as months after January 1st, 2014, did the rabbit population reach 10,000? So, okay, so we have reached 10,000. So basically what I can tell you, since this is quadratic, what's happening is, and let's see, would this be positive? Yeah, so I'm assuming it's sort of like some sort of a parabola, right? And so what's happening is here we have 10 hitting 10,000 here and then 10,000 here, right? It's going to hit at 2 different points. So they're saying we've got what? And P is in thousands, right? By the way, so P is just going to equal 10. Yeah, we're just trying to find the values where it equals 10. So this is how I would do it. I plug in our 10 here for population equals, and we've sort of got, and see, you know what? This is actually not nearly as crazy as I thought. I just realized something. So 10,000, look what's happening over here. You've got this constant. It's kind of like this value, 10, is just sort of sitting out here. And we know, therefore, that when this whole section here, if and when it goes to 0, we're going to get a population of 10. So all we have to do is figure out the 2 values for M that's going to send it to 0. So look what's happening here. 1.5 is the first one. You know why? Because, hey, guess what? They're saying in February, sometime in February. That's about a month and a half from January 1st, right? That's what is saying, that's what's creating the 0 value for this function with regards to the February month is 1.5. The other one that they have not addressed yet is 8.5, right? So at what other time? Now, I guess, see, they put it as a month February. So I think we can just enter a value of 8.5. Obviously, we can't enter the month because this always has to be in numerical form. So let's go ahead and back. But you see, I hope you guys that makes sense. Really, all we're trying to do is zero out this entire expression, and there's two places to do it, here and here. And we can just assume that this one has been used for February because of the time frame. So let's go ahead and throw in 8.5, right? Because you see here it has to be some sort of a number. And that's basically it. Oh, that one makes sense. All right, let's go to the next one here. All righty, let's clear this. All right, the hang time of a football is the amount of time the football stays in the air after being kicked. The height in meters of the football above the ground at time t can be modeled. All right, so this is again by this quadratic equation. Now look, I can always already tell you, the trajectory of a football is going to be like whoosh, like that, right? And this is literally what's happening. This is going to be sort of an upside down parabola, which looks like this, and it's going to track this path of a football. Which of the and you can literally think of the x-axis, which would go down here, as the ground, okay? Which of the following equivalent expressions displays the hang time of the football as a constant? Which of the following equivalent expressions displays the hang time of the football as a constant or coefficient? Okay, so what are they talking about here as a constant or coefficient? So what have they done? They've basically, see, I'm trying to understand. Oh, I see what they did. So what they've done is, God, see, it's like such a convoluted way of trying to essentially, like, what they're doing, in my opinion, because this is a strange question, but I believe they're asking you to complete the square. They're trying to get you to turn this into vertex form, and that's all that's going on. So I'm going to go ahead. And by the way, if you're on Instagram right now, and you want to check out the live stream, see the problems being solved live, go to my YouTube channel, go to YouTube, search for Scalar Learning, and you can check it out and actually see what I'm doing on the screen. So I'm going to complete this square. So I'm going to say, oh, but we got a decimal. See, this makes it a little more complicated. Let's see. Can we pull out 4.9 times 4? Yeah, we can. So we can actually factor this whole thing by 4.9. They gave us numbers where it's nice like that. We can do t squared plus 4. Just sort of doing this mentally, I can tell that 4 times 4.9 is 19.6. But if you didn't know that, this is a calculator question, and you can do that yourself, okay? And then t squared plus 4, t plus 2, t plus 2 squared equals h of t. Now, this is almost, we could do a difference of squares, but we can't because it's a plus 2. Oh, wait, no, sorry. Never mind. We can do, this has to be a minus 2 because we're factoring out a negative 4.9. So that has to be minus 2, so minus 4. T squared minus 4, and then they're completing the square is what I believe they're doing. Taking half of this value and squaring it. So it becomes negative 4.9 times t squared minus 4 and then plus 4. But you see what's actually happening is that means we're changing the equation. We're adding negative 4.9 times positive 4. We're adding a 19.6 to this equation just out of the blue. You can't do that. So since we're adding a negative 19.6, we have to add a positive 19.6 to cancel that out. So it's really just zeroing out. We're not modifying this equation. Now we can factor this and say negative 4.9 times t minus 2 squared. That's what this factors to. I'm kind of skipping some steps, like basically this factors to t minus 2, right? You can sort of see that if you're familiar with factoring. And then we've got, now we've gotten this thing for completed as a, we've done completing the square. And now it's in vertex form. And I think you see, look, this is literally what this is. So they say this little thing displays the hang time of the football as a constant or a coefficient. I mean, really, this is, you could say that what this is the vertex. This is the highest point. This is saying at 2 seconds, it's 19.6 feet high. Okay, and that's right. These other ones, I can't even tell you exactly what's going on and what they're trying to do, but convoluted way of asking you to complete the square. So let's see if that's right. Oh, and it's not right. Man, I'm 2 out. This one is 4.9. What's happening? The time when the football reaches the ground will be apparent when the equation is in factor form. This form, while equivalent, does not reveal the hang time. So let's read the explanation. In order to see the hang time of the football, we must write the equation in factored form. Also, they just factored out this, and they tell you t equals 4. Oh, I get it now. Okay, I get it. Now I see what they're saying by hang time. They were saying at what time it hits the ground again. Okay, so what they mean by hang time, let's see, I misunderstood it when I was reading it, and this can happen. They mean how long is it in the air on this trajectory until boom, it hits the ground. And that's what they're trying to do, which is basically the zeros of the function. Oh, it's 2 today that I missed. It's pretty bad. So we've got, it's this whole trajectory. So basically we need to find this value here, which will be the time value. And that's where it's going to hit. That's why B, actually, if you factor it here, you get that. Okay, this gives you the vertex. This gives you this point. This gives you the highest point. That's what they meant by hang time, the total time that it's in the air. So, all right, chalk that up to a misunderstanding. It's pretty bad. All right, let's turn it around. We got 2 left. Oops. Let's see here. All right, question number 4. Still redeem myself. Let's see what we got. Okay, here we go. Kai throws a stone vertically upward from a bridge. This is, again, this guy, nice quadratic equation. And it's like, it's going to go, whoosh, it's going to be one of these guys again. The height in meters can be modeled by the quadratic function. How many seconds does the stone hit the water? Boom. Okay, guess what? This is literally the same as the last question. We want to know when it's going to be here, right? When it's hitting that 0. We got to factor this guy, okay? And let's see if it factors nicely. Let me give it a shot. Yeah, you can pull 4.9 out of everything because 8 times this will, well, let me show you what I mean. So we're going to factor it like this. We got negative 4.9 on the outside. We got t squared left here. We got plus 2t because 2 times negative 4. Oh, sorry, it's minus 2t, excuse me. Minus 2t because 4.9 times negative 2 is positive 9.8. And then we've got, again, minus 8 because minus 8 times minus 4.9 gives us this 39.2. And now we should be able to factor this pretty easily. Negative 4.9 times t, let's see, it's going to be minus 4t plus 2. I don't know if you guys have done a lot of factoring. The way you factor is you figure out when you FOIL this again, you're like, okay, it's going to come back. We go, FOIL goes like this. First, outside, inside, last. So we do the first terms first, and we get t squared. We do the outside terms next, t times 2 plus 2t. Then we do these guys, negative 4 times t minus 4t. And then we do these last guys, minus 8. And these guys combine to be t squared minus 4t minus 8. And that's exactly what we had up here. So I'm just proving that we've, in fact, factored it correctly. So let's go back to this guy. This is our magic equation. Because now we can find our zeros. Our zeros are where this right here, t minus 4 equals 0, because that would zero the entire thing out. Or where t minus 2 equals 0. All right. T plus 2. T plus 2 becomes t equals negative 2. Negative 2 seconds. That doesn't really make sense. Here's t equals 4 if we add 4 to both sides. 4 seconds. That makes sense. C should be our answer. So, and I mean, you could even try it again. Like if I just plug it in here now and think about it. 4 squared is 16. This is roughly 5. That would be negative 80 here. Okay, negative 80. just approximating. Here we have 4 times 10, which is like positive 40. And then here's another positive 40 approximately. This all goes to 0. So that means 4 seconds is when this guy is going to hit the ground. Let's make sure we have an unlucky day today. All right, so that's good. That is correct. Let's do this last one. Here we go. Final question of the day. And then I got to get out of here. Oops. There we go. I think this works. All right, it's a long one. An umbrella sprinkler is positioned on a ceiling at a point whose x-coordinate is 0. Okay, let's see. X-coordinate is 0. So there's the sprinkler. And let's see. Oh, I got it. I think this is meant to represent the water coming down. Negative values of x indicate distances in meters to the left of the position, okay, of the sprinkler. So they're saying the negatives just mean, hey, we're going to the left instead of the right. The path of the water from the sprinkler can be modeled by this guy. Okay, here's our quadratic equation, which gives this curve. It's parabola, where Wx is the height of the water, meters at position x. Which of the following equivalent expressions displays the height of the ceiling as a one of these guys again? Okay, the height of the ceiling. Okay, now we are talking about vertex form. The last time we were talking about the time when it comes back and hits the ground, right? But now it's just saying, hey, what's the height of the ceiling? Meaning the sprinkler is on the ceiling, right? Doesn't it say that? Yeah, it's positioned on the ceiling. So we want to know what is this value. And that value is right at the vertex. So I can confidently say we have to complete the square. So let's go ahead and do that. And let's say 1/4 times x squared minus 12. Okay. Now we have to complete this. You take half of this to do. Oh no, we can't because wait, there's no middle term. X squared minus 12. So we have to think here. We have to say then that because we have no middle term, x squared minus 12. Oh, I see how we do this. Now this isn't going to work. So we have to actually distribute this guy. So we have negative 1/4 x squared. Let me think about this for a second. Minus 3 or plus 3 x squared plus 3. And then we have 0. Oh, easier than I thought. All right, I just figured it out. If we go ahead and distribute this, this would be negative 1/4 x squared. And then this guy would go there and it'd be plus 3. It's the first expression. And the reason why this is the height, because x at the vertex point, it's saying it's right at where x equals 0. Here you can just plug in 0 for this guy, and that goes away, and your value should be 3, and your height should be 3. Let me plug this in. Even if we just plug it into the original 0 minus 12, negative 12 times negative 1/4 is positive 3. So here we can see it. All right, learning how to do these problems. I hadn't seen something like this before. It's just a bizarre wording. So frustrating. Let's see if this makes sense. All right, fingers crossed. Yeah, boom. And let's just read the explanation if I can get down there. No, it won't let me. Okay. Doesn't give an explanation here, but that's the gist of it. So hopefully now that's taught you through my through some of my mistakes and discussions and explanations. Now you can understand as well how to tackle those problems. So let's go back here to my good old non-shared screen. Whoops. All right. See if you can see me. All right. Excuse me. So that's it. I hope that was helpful, guys. And again, now it is going to be the weekend tomorrow. So we'll pick up next week with these live streams of SAT problems. I wish you the best of luck in your test preparation process and have a great weekend. We'll see you guys next time. And again, Instagram, check out my YouTube channel, search for Scalar Learning on YouTube. You will find it. Thanks, guys. Take it easy.